Welcome to This Explainer. Imagine this for a second. What if literally overnight, every single ounce of cement just disappeared from Earth? We're talking buildings crumbling, bridges collapsing, the whole shebang. Civilization as we know it would just grind to a complete halt. It's a totally wild thought experiment, right? But it actually forces us to take a really close look at a material we completely take for granted. A material that's actually a massive, highly engineered scientific marvel. So it really begs the question, could we survive without cement? Well, today we are unpacking our kind of dangerous reliance on this gray powder. We'll break down the microscopic magic that actually gives it its strength, uncover a massive environmental crisis that's literally hiding in plain sight, and then look at some jaw-dropping futuristic alternatives that just might save our infrastructure and, our planet. Let's dive in. Okay, check out this absolutely staggering number, 1.3 billion. That is the number of tons of cement we produce globally in just 1996 alone. And honestly, production has just skyrocketed since then. Cement is literally the foundation for global infrastructural development. We obviously can't just stop building, but as we're going to see in a bit, we also absolutely cannot keep producing this much traditional cement. Section 1. A world built on cement. Because look, cement isn't just some modern convenience, it's the historical backbone of human civilization. We've been on this quest for the perfect binding material for millennia. What you're seeing here is the oldest surviving cement kiln in the UK, dating all the way back to 1847. But the real scientific breakthrough, that actually happened earlier, back in 1756. This guy, John Smeaton, was tasked with rebuilding the Edstone Lighthouse, and through his experiments, trying to find anything, that could withstand brutal seawater, he discovered that limestones containing clay yielded these really superior hydraulic properties. That spark eventually led to the creation of Roman cement around 1800, which was the direct forerunner to the Portland cement that totally transformed our modern world. Moving to Section 2, the magic of hydration. So how exactly does this dusty powder turn into rock-solid infrastructure? Well, I promise to totally demystify this for you, because the science happening down at the microscopic level is just incredible. Most people think cement just sort of dries out to get hard. But actually, scratch that. It doesn't at all. It undergoes a process called hydration. It's this highly active chemical process where the compounds in the cement literally react with water to form a totally new, super strong, solid gel-like mass. If you take that water away too soon, the reaction stops dead in its tracks and your concrete ends up really weak. Inside that unassuming powder are these tiny, tiny crystals. We're talking about a quarter the thickness of a human hair. They're just 15 to 20 microns. When water hits them, the chemistry happens right there on the surface of those grains, sprouting this binding substance we call calcium silicate hydrate gel, or CSH gel for short. When this gel forms under dense compaction, the whole thing interlocks and yields massive compressive strength. But guys, here is where it gets absolutely fascinating. Because we often use a really low water to cement ratio to get that high strength, not all of the cement grain actually reacts. You end up with this unhydrated core left inside the hardened structure. And guess what? This is actually a hidden reserve of strength. If the concrete eventually develops microcracks over time and a little moisture seeps in, boom, that dormant, unhydrated core will finally react with the new water, create even more gel, and literally help seal its own microcracks. It's like the concrete has its own biological immune system, just waiting to heal its own wounds. No way, right? Okay, Section 3, the 7% problem. Despite all that chemical brilliance we just talked about, we have a massive issue. And this right here is exactly why we might actually need cement to disappear. There is a pressing environmental crisis threatening its very future. 7%. That is the amount of all global greenhouse gas emissions directly attributable to the Portland cement industry alone. Just to put that into perspective for a second, if the cement industry were a country, it would be one of the top polluters on the entire planet. Let's break down exactly why this environmental toll is so incredibly heavy. First, we have the chemical reality. For every single ton of cement produced, about 0.87 tons of CO2 are just blasted right into the atmosphere. Second is the sheer amount of energy required. The kilns used to bake the raw materials have to reach 1,400 degrees Celsius. I mean, that is literally hotter than volcanic lava. Because of this extreme heat, cement manufacturing accounts for roughly 80% of the entire concrete industry's power consumption, all while devouring vast, vast amounts of natural limestone. We simply cannot go on producing cement this way indefinitely. Which brings us to Section 4, building a greener mix. The industry is currently scrambling to find immediate, practical ways to drastically reduce our reliance on traditional, ordinary Portland cement. If traditional cement really did suddenly vanish, here's how we'd survive. Take a look at this massive concrete foundation laid at Kauai Island in Hawaii. Engineers actually designed this to last for at least 1,000 years. How on earth do you do that? Well, they did it by replacing a massive 57% of the traditional Portland cement with a supplementary material called fly ash. By just altering the recipe, they created this highly durable, incredibly eco-friendly foundation. So what exactly are these magical substitutes? Well, they're actually industrial byproducts coming to the rescue. We're talking waste from burning coal, that's the fly ash, slag from steel manufacturing, silica fume from making silicon alloys, and highly reactive metakaolin. By blending these waste products into the cement, we achieve this amazing synergistic effect. We get tailor-made, highly durable concrete, and we keep massive amounts of industrial waste out of landfills, all while drastically cutting down on those CO2 emissions from traditional cement kilns. It's pretty much the ultimate win-win. Now for Section 5, Bacteria and Polymers, the future of concrete. Remember our question? What if traditional cement really did disappear from Earth? Well, here is what a slightly sci-fi-esque world without it might actually look like. So on one side, we have your traditional OPC, high heat, massive CO2 emissions, relies on standard cement paste. But on the other side, we have geopolymer concrete, and this stuff is revolutionary. Synthesized entirely from silicon and aluminum-rich industrial waste, geopolymer concrete uses zero traditional cement, literally none. Instead of that CSH gel we talked about earlier, it uses an alkaline solution to activate the fly ash into this inorganic polymer. And the real kicker? It cures ultra-fast, often in just 24 to 48 hours. Then we have the pursuit of pure raw strength with macro defect-free or MDF cements. See, normal concrete has these microscopic voids and entrapped air that basically limit how strong it can get. But with MDF processing, engineers add a small amount of water-soluble polymers, and then they literally press the mixture using warm pressing at 5 megapascals of pressure. This squeezes out the microscopic defects and totally eliminates large voids. The result? Unbelievable compressive strengths of up to 300 megapascals. To put that in perspective for you, normal building concrete sits around 30 to 40. We are talking about the difference between holding up your driveway and holding up a skyscraper. Okay, but my absolute favorite advancement is right here, bacterial concrete. Just imagine turning a static, lifeless wall into a living, self-healing entity. Scientists are successfully infusing concrete with a super common soil bacteria called Bacillus pastori. These incredible little microbes actually secrete calcite, which is a natural cementing material, to naturally and biologically seal cracks and fissures right from the inside out. Let's just walk through how this magical self-healing process actually works. So over time, microcracks naturally develop in concrete, right? It's just from weathering or stress. When moisture enters those tiny cracks, it wakes up the dormant Bacillus pastori bacteria that are just waiting inside. The bacteria wake up, begin to metabolize, and secrete that calcite we mentioned. As the calcite precipitates, the cracks are naturally, biologically sealed, and it completely restores the strength and durability of the structure. It's super environmentally friendly and drastically extends the life of the building. So I'll leave you with this. If traditional cement disappeared from Earth tomorrow, would we survive? The answer is a resounding yes. From Roman kilns to tomorrow's cities built with living, self-healing bacteria, our world might just be replaced by a world built on biology. Thanks for joining me on this explainer, and keep your curiosity strong.